When lightning strikes, the air around the bolt instantly heats up to 30,000 degrees Celsius. That is 5 times hotter than the sun's surface, carrying up to 1 billion volts of electricity. When that immense energy hits a non-conductive object like a tree, the sap inside boils in a fraction of a second, expanding explosively and shattering the trunk from the inside out. Logically, a human body, which is largely water and fragile tissue, should be instantly vaporized by that exact same extreme heat and voltage. Yet, between 80 and 90% of people who are struck by lightning survive the impact. Surviving a billion-volt strike implies there is a physical loophole at play. To understand how the human body endures this, we have to look at how that electricity is generated in the atmosphere and how our skin acts as a temporary electrical conduit. A lightning strike requires massive atmospheric architecture. Billowing cumulonimbus storm clouds can tower up to 20 kilometers into the sky. Inside these towering structures, powerful updrafts and downdrafts create a highly chaotic environment. Billions of freezing water droplets and ice crystals are constantly colliding. Every micro-collision transfers electric charge. Positively charged ice crystals are pushed upward, while negatively charged hail sinks. This heavy negative charge at the cloud's base repels electrons in the Earth, leaving the ground heavily layered with a positive charge. The storm cloud now operates as a massive, highly unstable battery. Because nature attempts to correct severe electrical imbalances, a violent discharge between the sky and the ground becomes unavoidable. The strike begins with a stepped leader. This is a faint, invisible channel of negative electricity moving downward in short, branching steps, searching the air for the path of least resistance. As that negative leader approaches the ground, positively charged objects below, tall structures, isolated trees, or even human bodies, send up invisible positive streamers. When the descending leader and an upward streamer connect, the circuit closes. A surge of electricity races upward, creating the blinding return stroke. The iconic branching zigzag pattern of that stroke is simply the electricity constantly redirecting itself through varying temperatures and moisture to maintain the easiest route. When a human is the upward streamer, this entire electrical circuit opens and closes in roughly 0.2 of a second. This microscopic duration creates a phenomenon called a flashover. Because the burst of energy is incredibly fast, the electricity usually sweeps over the moisture on the surface of the skin, rather than penetrating deeply into internal organs. This intense surface-level heat boils sweat and rainwater instantly, occasionally leaving temporary fern-like branching burns, known as Lichtenberg figures on the victim's skin. The extreme brevity of the strike, combined with this surface-level flashover effect, creates the exact physical conditions that prevent a human from being instantly vaporized. However, surviving a flashover does not mean walking away unharmed. The human body still absorbs massive secondary trauma from the sheer force of the event. For the 10 to 20% of victims who do not survive, the intense electrical shock disrupts the nervous system, which instantly triggers cardiac and respiratory arrest. The heart and lungs simply stop functioning. Even for survivors, the sudden violent muscle contractions caused by the current can easily snap bones and dislocate joints, while the massive acoustic shockwave of thunder can rupture eardrums. Standing in an open field or taking shelter beneath an isolated tree during a storm physically transforms your body into the tallest upward streamer in the vicinity. You are volunteering to close the circuit. To avoid becoming part of that circuit, meteorologists rely on the 30-30 rule. If the time between seeing a lightning flash and hearing thunder is 30 seconds or less, seek shelter indoors and remain there for 30 minutes after the final clap of thunder. While physics and surface moisture allow the human body to endure an impact that shatters solid wood, the only reliable defense against a 1 billion volt discharge is ensuring you are never in the path of the current to begin with.